A lot of data engineering videos and roadmaps online will tell you to learn SQL, Python, and AWS, etc. to become data engineer. But the main reason people fail to become a data engineer is because they are not understanding the big picture of exactly what a data engineer actually does, why a specific tool is used, or how it all ties together. So, in this video, I'm exactly going to uncouple all of that. Hi, this is Nick. If you're here in the Pipecode channel for the first time, welcome. I'm a senior data engineer with over 8 years of experience at companies like Microsoft, TikTok, etc. I've been in both sides of data engineering interview table for over 500 plus interviews. And today, I'd like to present you how to become a data engineer in 2026. In order to understand everything better, let's break it down into four main steps. Number one, what is data engineering? Number two, what do data engineers actually do? The skills, tools used to perform the data engineering tasks. Number three, how to get started, because a lot of tools and skills are there that you can learn and it's an ocean, but a readily available action plan is what you need. And number four, how to practice all of it and actually learn everything and become a data engineer. Okay, let's get started. Number one, what is data engineering? Let's explain the data engineering in a classic city and water analogy. Let's say that there is a city with a lot of houses, offices, businesses, etc. The main way that city can live and function is through supply of water. But let's say that water is coming from a nearby lake or river. How does it all come together? It comes through a sophisticated plumbing system with dams, storage tankers, pipes, and plumbing. And then who builds all of these distribution systems? Essentially the plumbers. In the same way, now imagine a big company, just like a city, working on their businesses, products, improvements, and developments, having different teams like product, R&D, finance, HR, etc. Just like how a city has schools, offices, etc. The key and essential element for a company to run is data, just like water. So the people who build data pipelines to serve essential data to different teams are called data engineers. So in the city analogy, how plumbers do all the plumbing system, in a company, data engineers serves all the data into essential teams to run their businesses, maintain pipelines, etc. So we learned who a data engineer is. Now it's time to learn what does a data engineer does, what is the required skill set and tool set to make data engineering tasks better. To understand this, let's go to a visually interactive set, which I'm going to present right now. The first and essential step in data engineering is the data extraction. This is where it all begins. Let's start from the very beginning, the data extraction. Think of this as collecting ingredients before you cook. Imagine you're working in a big company like Amazon, where data is coming from everywhere. You need to understand where it all comes from. The first place is generally APIs. These are like digital messengers. When Amazon wants weather data to track delivery estimates, or it wants information from payment processors to track the fees so that they can process better, all of these third parties are communicating with Amazon generally through APIs. So, as a data engineer, you potentially deal with dozens of APIs. Next, coming to OLTP databases. So let's say a person places an order on Amazon. All of those transactions directly land into an OLTP database systems. OLTP is called online transaction processing. General databases that you hear like MySQL, Oracle, SQL Server, all of these things are OLTP databases. Our job as a data engineer to actually copy that data into somewhere else so that we don't affect production systems. The next place is event streams. Let's say you open the Amazon app and then you click, you do a page view, or like you place an order. All of those actions are simply called as events. Amazon has millions of users using the app every time. So these are millions of events per second that are flowing through into the system that we have to capture. Lastly, flat files. Sometimes data comes in an old-fashioned way, like CSV, Excel, spreadsheets, etc. So a business partner might email you a file or simply might drop a shared folder. It is very simple, but it's still very common. So what is your first job as a data engineer? Grab all of those sources and put it somewhere safe. To do this, you'll need to learn key and essential skill. That is the Python programming language. Most of the data engineers today use Python. Some people still use Java, but Python is your number one choice. So where does this all of this data goes? So all of this data goes into something called a data lake. So this is like a giant storage bucket. So in order to visualize in your mind, think of it like a giant folder.
that's there in your PC or Mac. All right, so at this stage, the data is raw and messy, but that's totally fine. We'll clean it up in the next phases. But again, like I mentioned, the data lake, right? So some of the solutions or tools that we use in data engineering day to day as data lakes are these ones. All right, before I get into those data lakes, for all the data extraction code that you're going to build in Python, you're going to actively manage that code and maintain it properly. So IDE and version control tools like VS Code, GitHub, etc., are going to be helpful for you in this stage. And then all of this data, as I told before, gets dumped into a data lake. So you can see S3, Azure Blob Storage, Google Cloud Storage, etc. These are the sample data storages or data lakes that you can use. All right, let's move into the next step. Up next, we're going to talk about a very important step in the data engineering process, ETL. ETL is nothing but extract, transform, load. So extract means pulling the data from somewhere, like the data lake, which we have explained earlier. Transform means cleaning it up and making it into a useful format. And then load means putting the data into somewhere organized, just like a data warehouse, you can say, which we are going to explain at length in the next step. Here's a simple example. Imagine you have Excel sheet with all the customer names of Amazon. In the first step, in data extraction, we're going to collect all the data from the Excel sheet and put it into a data lake. And in the ETL step, we're going to extract all those customer names data and then put it into a data warehouse. But there is a step, transform, in the middle. What does that mean? In this customer names example, let's say there is a customer called John Smith, but that customer name is like written in three different places or three different rows in three different ways. Let's say the first way is whole caps, all John Smith is in caps. The second way is like whole small letters, all the letters in John Smith is in lowercase. And in the third place, it's listed with a mixed case where J and S are caps and other words are smaller. All of these three rows, let's say, constitute to a single customer. The transform step essentially takes care of that and then normalizes all of those three rows into small or large or caps to make it all equal and then to make the data uniform. This is a very small example of how transform works, but in the real world data engineering, transform is much, much complex. So the two skills that you need to absolutely learn in order to master this transform step are SQL and Python. SQL is a structured query language. It's an easy and communicatable language that you can write, talk to database systems to transform the required data. And then Python is a very good programming language. This is also pretty much used in the transformation step. Right. Now, let's talk about tools that makes this process even easier and faster. So tools like Fivetran, AWS Glue, Azure Data Factory, Apache Airflow. Apache Airflow, even though it's an orchestration tool, you can still use it for ETL, and dbteam. These are tools in different ecosystems that work as ETL tools where you can extract, transform, load all in one place. But again, so how to pick them, it actually depends on like specific use cases and the cloud ecosystem that you're working on or the open source ecosystem that you're working on. So if you learn one thing well, ETL is going to be it. This is what data engineers do on a day-to-day level. All right, let's jump into the next step, which is data warehouse. Think of data warehouse like a super organized library for your company's data. Instead of books on shelves, you have tables with rows and columns. Tables like sales numbers, customer information, product details, etc. When marketing needs to see which products are trending, again, data warehouses. When finance department chooses to build their report, again, data warehouse. Here's something I want you to hear loud and clear. You cannot become a data engineer without SQL. It is the universal language of data. You'll also hear about data modeling. This is just a fancy way of saying organizing your data so it's easy to find and use. Think of it like organizing your closet so you can actually find your clothes. The big tools here are Snowflake, Amazon Redshift, Google BigQuery. These are the cloud-based data warehouses. And then if you're looking for like a third-party unified analytics platform, Databricks is something which is very unified and third party. It's available in both AWS and Azure. And then Azure has its own unified platform called Azure Synapse. So, what I would recommend is spend most of your learning time on SQL. I cannot stress this enough. All right, now let's jump into the next step, which is data delivery. Data delivery is nothing but starting a business. Here's something beginners often miss: data is only valuable if people actually use it. Think about it. You've collected data, cleaned it up, organized beautifully, but if nobody can see it or use it, what is even the point? Data delivery is about getting the data into hands of people who need it. First, dashboards, visual charts and graphs that update automatically. These turn boring numbers into colorful, easy to understand visuals. Executives love these dashboards to understand and then see how the business is performing. Second, reports, automated emails, documents that go out weekly, daily, monthly, etc. For example, here's your sales report for Monday. Here's how many number of customers enrolled in the platform the last month, etc. Third, APIs. This is how computer shares information with each other. If Amazon wants to share information with a stakeholder or a third party, they don't share it over an Excel sheet in an email. They build APIs that partner system. So in terms of the skills that you need to learn for this step, again, Python and knowledge of REST APIs is key and essential. In terms of tools and technologies for the reports, dashboards, and business intelligence, tools like Tableau, Looker, and Power BI are going to be excellent choices. Let's now move into the next step of data engineering, which is last but not least, the data orchestration. This is what turns you from a beginner to a professional. Here's a problem. Everything we talked about, extracting data, transforming it, loading it into warehouses, delivering it into dashboards, needs to happen automatically every single day without you lifting a finger. You can't wake up every day in the morning at 6 a.m. and then run all of these jobs manually when you wake up, right? So that's simply not sustainable. So that's why we need orchestration in place. Think of it like a giant factory that's producing soft drinks. You can turn on the switch, the whole manufacturing process runs itself, all the way from like creating the drink to bottling it up to putting it at the end in the storage. Orchestration is simply like that. You turn on the switch, all the process runs by itself. The beautiful thing about good orchestration is like if let's say something breaks at 3 a.m., the system tries and attempts a rerun several times before it wakes you up. Once you fix an error, it runs smoothly on its own. In terms of a skill set that is used for this data orchestration is again SQL, Python, like we talked before, and another step called CI/CD, which I'm going to talk a little bit later. Right? The tools and technologies that are used for this data orchestration step. The first one is Apache Airflow. Apache Airflow is the number one orchestration tool that is used by companies like Airbnb and Netflix. You can also use simpler tools like GitHub Actions, etc., when you're starting out. dbt is also one very popular data orchestration tool. It's a combination of ETL and data orchestration tool. That's why you see it in the both places. Even Apache Airflow, even though it's popular for orchestration a lot, it also can be used in ETL tool. Now we see something called as like GitLab and Git Actions. Again, Git Actions can also be used for orchestration of other things, but mainly GitLab and Git Actions and the CI/CD that you see here. These are used for like the code maintenance, which I'm going to talk just in a second. So for the orchestration, we also have some cloud native solutions like AWS Step Functions, Azure Logic Apps, Google Cloud Composer, etc. Now, coming to the final step of maintenance, what is CI/CD? CI/CD is nothing but continuous integration and continuous development. Imagine a scenario where you just build all the data pipeline code in Python, and then there's one small business change or logic to a metric. You have to reliably and efficiently update the code in order for the data pipeline to run. That's where CI/CD takes place. CI/CD is nothing but a skill set which actively enables you to change the code reliably and efficiently. And GitHub Actions and GitLab are actually usually paired CI/CD tools that you will use to maintain the code. So yeah, this is essentially the whole data engineering system.
All right. We have seen about what a data engineer does and a lot of skills and tools used in data engineering. Now, learning all the skills and tools mentioned earlier is not only impractical but also unnecessary. So, how do you typically get started? Well, in order to become a data engineer, you need to crack the data engineering interview, right? So, let me give you an actionable learning plan to crack the data engineering interviews effectively. Step one, the first part of any data engineering interview is generally the technical screen round. In this, you will typically be asked SQL and Python questions. So you need to be thorough with both SQL and Python. That's the bare basic requirement. Step two, The next set of interviews, typically known as final loop or final round, generally test on skills like dimensional data architecture, system architecture. This is also called the system design, ETL and orchestration, metrics and visualization, and behavior interviews. To prepare for these interviews, I'd like to recommend you to learn skill set or tool set. For the data architecture, you need to learn dimensional data modeling concepts like OLTP, OLAP, normal forms, fact table, dim table, etc. For ETL and orchestration, I'd recommend you to start with learning one ETL tool. My favorite and pick for you for this is Apache Airflow, as it's the gold standard and one-stop shop for learning how to do both ETL and orchestration. Most importantly, do sample projects to get more understanding of the entire process. For the product sense and visualization interviews, I would recommend you start with learning one visualization tool, like Power BI or Tableau. Both are very competent and very industry standard tools. You cannot go wrong with either. Next, system design round. This is generally an overall architecture interview and it is only applicable for mid to senior level roles with at least 2 to 3 years of experience. This is where you take a case study and explain what kind of tools and technologies you would put in place to construct an efficient and reliable data pipeline that applies to that specific case study or use case. To prepare for this interview, I would recommend you to be a jack of all trades but king of none. What do I mean by that exactly? Well, here it is. The first step is like learning what a batch versus real-time pipeline is. What is a data lake? What are different data lakes? What are its advantages and disadvantages? What are different kinds of ELT versus ETL patterns that you have? What are different kind of ELT versus ETL tools that you have? What are their strengths and weaknesses? What is the plan for data delivery, orchestration, etc. Next one, behavior interviews. This is the interview where you will typically talk with a hiring manager or a business partner or even a HR, where you talk about your past experience, the projects that you did, and then the expected on job behavior. The recommended gold standard for preparing for this interview is Amazon Leadership Principles based behavior questions. Amazon gives a very high value for this round, and if you prepare for leadership principles interview of Amazon, you're generally good for all the other behavior interviews. So you can ask me, Nick, where do I learn all of these things together? Well, as of right now, there's not one single destination to learn all of these skills, tools, practice real-time interview questions, and even have demo mock interviews, especially targeted towards these data engineering interviews. And that's why we are building Pipecode. Pipecode offers quality data engineering learning content with easy to understand and highly interactive visual delivery. And then we also provide exact coding questions and data modeling questions from the big tech data interview loops. And we also provide a place to practice by utilizing AI powered mock interviews. We are going to launch our Pipecode product this Q1 2026. But if you're interested in the free early access of the platform, please hit the Discord link in the description and join our community to get premium early access to the platform. Thanks for watching this video and don't forget to subscribe to the channel for more data engineering content.